Mutual induction. As noted in our earlier videos, a changing magnetic flux in one coil, in this case we'll call it C1, links with the second coil C2 and induces an EMF in it. C1, in this case, becomes the primary coil, the one connected to the battery, and C2 becomes the secondary coil. The one connected to the galvanometer. This is called mutual induction. Mutual induction occurs when a changing current in one coil induces current in another one placed close to it. Changing current in one induces current in the other coil. The following diagram is a representation of the change in magnetic flux that occurs between the two coils. So the first diagram represents the primary coil. You can call it diagram 1. And diagram 2 represents the secondary coil that is connected to the galvanometer. So as a result of a changing magnetic field, magnetic flux linkage, an EMF will be induced in the secondary coil, which drives current as shown in the as indicated by the deflection on the galvanometer. In mutual induction, the following observations serves as an evidence of the existence of the induced EMF in the secondary coil. So when the switch is closed, it is observed that the pointer deflects in one direction. And then comes back to zero. When the switch is open, the pointer deflects in an opposite direction to that when it was closed. and then comes back to 0. The degree of deflection of the pointer is observed to be higher when more cells are used or a higher voltage is provided in the primary coil. So when the switch is closed and more current is provided, then the degree of deflection of the pointer also changes. When the DC is replaced by an AC, the pointer vibrates about the 0 point. This is because of the continuously changing magnetic field. It is important to note that there are various ways through which the induced EMF can be increased. One, in winding the primary and secondary coils on a soft iron rod. This is because the soft iron rod concentrates the magnetic flux in both coils. Soft iron ring can also be used since the ring enables all the magnetic flux of the primary to form concentric loops within it, thus reaching the secondary coil.